All right, guys, we're going to do a second review right here. And yes, I'm using my creepy voice. No, I'm just kidding. Well, anyways, I'm not yelling because I'm not teaching in front of the class. So we're going to work on this second review. We're going to break it up into pieces. This first piece is going to be on radicals and exponential equations. So let's take a look at number one. It's a square root of 45tu to the fifth. We're going to split the root to each and every one of the terms. Let's do the number first. The square root of 45, it's not a perfect square number, so you want to rewrite it with multiplication to get a perfect square number. So 9 times 5 is 45. And when we split the root, we'll be able to do the square root of 9, which is 3, and the square root of 5 is going to stay the square root of 5. Now, let's take a look at the square root of t, and also the square root of u to the fifth. Now, the square root of t, there's nothing to do there. You can't do anything, so we're just going to bring it down, square root of t. And then we're going to take the square root of u to the fifth. See, we know that the square root is really the power of 1/2. So we want an even exponent. We don't want the power of 5. We want an even exponent like 4. So let's rewrite u to the fifth as u to the fourth times u, because after all, u to the fourth times u is u to the fifth. And then I'm going to split the root, and the square root of u to the fourth, remember the square root is really the power of 1/2. That's kind of like putting a u to the fourth right there, and a power to a power you multiply. So u to the fourth to the 1/2, you multiply those, and you end up with u to the second. See, the reason why we want an even powered exponent is because the square root is the power of 1/2. So it's kind of like saying 4 divided by 2. And we end up with u squared, no more square root. And of course, the other u, square root of u, that just comes down. So what we do now is put all the items that are on the outside of radicals out in front. So I do have a 3, also a u squared. And then I'm going to take all of these radicals and put them all together underneath one radical, underneath one square root. So that is a 5, a t, and also a u. Ladies and gentlemen, that is your first answer to number one. Number two, whenever you have a square root of a fraction, you have to split the square root. So we're going to put the square root of 7 over the square root of 3x squared. And it's kind of like doing two separate problems. However, when you look at the top, there's nothing to do there. The square root of 7, you can't break it down with multiplication. There's nothing to do. This bottom one, you could split the square root. So let me do this down here. The square root of 3x squared, I'm going to split the square root, make it the square root of 3 and the square root of, the square root of x squared. And the square root of x squared, that is just x, no more square root. And the square root of 3, you can't do anything with that. So what I'm going to do is rearrange it. I'm going to put the x first and the square root of 3 second. So in reality, this guy becomes x square root of 3. And you still have the square root of 7 up on top. However, you cannot leave a radical in the denominator. So you must multiply both top and bottom by that same radical value. So if you don't want the square root of 3 down here, you have to multiply by that exact square root of 3 value, both top and bottom. So anyhow, we should know that when we multiply the square root of 3 times the square root of 3, that's just 3. No more square root. Whenever you multiply a square root with itself, the square root disappears and the inside value is your answer. So on the bottom, we truly have x times 3, no more square root. Now up on top, you could actually multiply the square root of 7 times the square root of 3, put those together. You get the square root of 21. Now you can't do the square root of 21, you can't even break it down to simplify it, so that's about it. The only other thing you could do is write it with the 3 in front of the x. That'd be your best answer. The square root of 21 over 3x. That is the answer to number 2. Let's move on to number 3. And once again, you want to split the root. Split the root, 11k over 12. And up on top, there's really nothing to do. But on the bottom, I'm going to do the square root of 12 over here on the side. 12 is not a perfect square number, but I could rewrite it as 4 times 3. That way, when I split it, I could actually do the square root of 4. The square root of 4 is 2. And the square root of 3, you're just going to leave it, the square root of 3. So it's clear that the square root of 12 is the same thing as 2 square root of 3. So I'm going to take the square root of 12 and I'm going to rewrite it as 2 square root of 3. And up on top, we still have the square root of 11k. Again, you can't do anything with that top square root value. So on the bottom, I have a square root of 3. I can't leave it down there. I need to get rid of the square root by multiplying by that same square root value. And what you do to the bottom, you must do to the top. And now, once again, when you multiply a radical with itself, a square root with itself, the square root disappears and you're left with just the number inside. So in the denominator, we have the 2, and we actually have a times 3 instead of square root of 3 times square root of 3. So in the denominator, we will have 6 on our final answer. Up on top, when I multiply 11k times 3, we're going to put those together. That'll simply be 33k. So our final answer is square root of 33k over 6. Right here we have a fourth root, and a fourth root, obviously, you need to ask yourself what number times itself 4 times will give you this inside value. So how do I recommend doing this? I would you're able to use calculators. Just pick a number, let's say 5. I'm just guessing here. 5 to the 4th power. Let's see if it equals, no way, 5 to the 4th power is 625. It's too small. So let me up it, maybe 7. 7 to the 5th power. No, to the 4th power, I'm sorry. That's it, I guessed it, 7 to the 4th power. So I tried 5 to the 4th power, it was too small. I mean, you could try 7 to the 4th power, you see that's it. But it's just a question of guessing and checking. Of course, you could break it down, but the easiest way to do it is to just, on your calculator, type in, 7, and then the caret button to the 4th power. That's 7 to the 4th. 7 to the 4th really is 2,401, which means that the 4th root of 2,401, the answer is just 7. Square root of 28, number 5. There is no, square root of 28 is not a perfect square number. So you want to rewrite it with multiplication to get a perfect square number. So what times what is 28? 4 times 7. And 4 is a perfect square number. So 4 times 7, split the root, choose square root of 7, you're done. That's all you could do with number 5. Number 6. Remember, the 1/3 power is the same thing as the 3rd root. So here's a little bit of notes for you. A square root, you don't have to put the 2 right there, because when you don't have a number, you automatically assume it's a square root. But anyway, we know that the square root is really the same thing as the power of 1/2. And we should know that the 3rd root is really the same thing as the power of 1/3. And the 4th root is the same thing as the power of 1/4. And so on and so on. Okay? So right here, what do we see? We see a certain number to the 1/3 power. So in reality, they're asking us the 3rd root of 729. Now, the question is, what number times itself 3 times will give you 729? And once again, I would use the calculator and just pick a number, maybe like, let's say 5 to the 3rd power. That's not going to be 729. If I do 5 to the 3rd power on a calculator, I get 125. We already knew that was too small. So pick a bigger number, maybe like 7 to the 3rd power. That's 343. It's still way too small. Let's try 9 to the 3rd power on a calculator. 9 to the 3rd power is 729. So that's the answer, 9. Why is the answer 9? Because 9 to the 3rd power equals 729. And that's what we're looking for. We're looking for a number times itself 3 times that'll give us 729. Okay, so 9 times 9 times 9 is 729. So the answer is 9. Let's move on to the next one. Oh yeah, this one looks fun. Okay, so let's break it all up, huh? Break it down. Break it up, break it up, break it up. Okay, anyways, 126 x squared y to the 4th z to the 5th. So 126 is not a perfect square number. So you might want to have a perfect square number list handy. So there are your perfect square numbers. So this is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. So, I mean, you could just get a calculator and try like 126, try dividing it by like 49, it's not going to work. Try dividing it by 36, it's not going to work. And if you keep trying to divide by all these perfect square numbers, they won't even work with 4. 126 divided by 4 won't give you a nice whole number. It's a decimal. But 126 divided by 9 is 14. So you're going to rewrite it, 9 times 14, and then you're going to split the root, which means that you will have 3 square root of 14 as this part of our answer so far. Now, if you look at the next one, the square root of x squared. Remember, taking the square root of a variable with an exponent, it's kind of like dividing the exponent by 2, because a square root is really the power of 1/2. So I'm going to take this and divide it by 2. And what do I get? I get x, just x. No more square root. So I'm going to bring it down right there. Actually, let me just bring it straight down so nobody gets confused. Bringing it straight down, just x, no more square root. And then when we look at the square root of y to the 4th, that would be y to the 2nd, no more square root. Again, the square root is a power of 1/2, so it's kind of like saying 4 divided by 2 is 2, no more square root. Now, this one is an interesting one. This one's the one that we have to actually do a little bit of work. Again, we want an even power right here. You don't want an odd power, because remember, it's kind of like dividing by 2. So you don't want to divide 5 by 2. It would be nicer to divide 4 by 2. So what I'm going to do is I'm going to rewrite z to the 5th. I'm going to rewrite it as z to the 4th times z, because after all, that is z to the 5th. And what I'm going to do now is split the square roots. And then that way, I could actually do the square root of z to the 4th. That's just z to the 2nd. It's like dividing 4 by 2. And then the square root of z, that just comes down. And now all of this is my answer. All of these guys are my answers, but I need to organize it. Okay, now what do I mean by organize it? I need to put the nice terms that are outside of the roots, I need to put them first and in order. So I'm going to put the 3 first, so equals 3. And then x's, there's only one x outside of the square roots, right? There's just one x right there. And then y squared, z squared. Those don't have square roots, so let me write them on our answer. Y squared, z squared. And now it's time to write what we do have inside the roots together. We have a square root of 14 that can't be broken down any further. And we also have the square root of z. So let's put the 14 and the z together underneath one square root. So I'm going to put square root 14z. And that's it. That's your final answer. Let me box it in red. That's your final answer for this problem. Let's move on to number 8. Okay, well, I believe I made a typo right here on this one. Let's change this 243 to something that you could actually take the 6th root of. So let's change that to a 729. Okay, so it's not 243. Let's change it to 729. Now the reason for that is you could actually do the 6th root of 729. I think I made a mistake when I printed out this practice test. I apologize. Anyhow, let's split up the square root of 6 to each of the terms. Not the square root of 6, the 6th root. I'm sorry. We're going to split the 6th root to each of these terms. So that's what we end up with, splitting up the 6th root. And of course, I changed it to 729 so it'll work out nice and neat. With the calculator, just start guessing. 2 to the 6th power, will it give you 729? It won't work. If you try 3 to the 6th power, it will work. Okay, so 3 to the 6th power is 729. So we know that the answer, the 6th root of the 729, that is just the number 3. Okay, now let's take a look at what a 6th root actually is. The 6th root is really the power of 1/6. So remember, when we had a square root, we wanted this to be divisible by 2. If you had a 3rd root, you would want it to be divisible by 3. If you have a 6th root, you want it to be divisible by 6, which it is. So a to the 12th, when you take the 6th root of it, it's simply dividing 12 by 6, and you will get a to the 2nd. Okay, now let's look at the next one. 14. 14 is not divisible by 6. It's not. So what we want to do is rewrite it so it can be divisible by 6. So I'm going to take b to the 14th, and I'm going to rewrite it as b to the 12th times b to the 2nd. Now, why would I do that? Because when I split the 6th root and the 6th root, then I will be able to do this one. The 6th root of b to the 12th, that's like saying 12 divided by 2, that is b squared. But the 6th root of b squared, you just leave it, the 6th root of b squared. Now let's do the same for this last one over here. The 6th root of c to the 19th. 19th is not, 19 is not divisible by 6. So I'm going to rewrite this whole thing with multiplication to get something that is divisible by 6. So I'm going to rewrite it as c to the 18th times c. That's really the same thing as c to the 19th. So now I could split the 6th root, and I could do the 6th root of c to the 18th, that is c to the 3rd, and the 6th root of c, that's just going to stay the 6th root of c. So here's our answer, 3a squared, let me write it, 3a squared, and then I also have the b squared, and I also have a c to the 3rd, and now what I'm going to do is write my radicals, the 6th root, I'm going to write them together. So I'm going to have the 6th root of b squared c. And ladies and gentlemen, that is our answer. Jumping to the next section, write each expression in radical form. We already know that the power of 1/2 is the square root. However, right here we see that z to the 1/2, that's the square root of z. The only thing that has the power of 1/2 is z, not 16. So this really becomes just a 16 in front and the square root of z. So that is your answer, 16 square root of z. Let's move on to number 10. Right here, we want to change the square root to an exponential form, all right? Or an exponential to a root. So right here we have a root, we want to change it to the power of, and we already know that the power, or the square root is the power of 1/2. So notice we have this whole thing in here. I'm going to write that whole thing, the 13b, inside parentheses, and the square root that's right here, I'm going to rewrite it as a power of 1/2. So ladies and gentlemen, that is our answer. 13b in parentheses to the power of 1/2. That's the answer. Let's move on to the next one. Number 11. We want to change this exponent of 1/2 back to a radical. Okay, so we know that this is the square root, and notice that it does have parentheses around the whole thing. So this whole thing is going to be inside the root. It would be totally different if we didn't have those parentheses. But we do have the parentheses, including the 3, the x, and the y. So that's why we include the 3, the x, and the y inside the root. Okay, so if we didn't have the parentheses, if we didn't have these guys, the y would be the only thing inside the square root and the 3x would be on the outside. But because we have the parentheses, everything is inside the root. Let's move on to the last couple of problems here, solving equations. Right here the trick is to get the same base. We have the base 6, so if we could change this to be 6 to a certain power. So once again, we have 6 to the x plus 3. And we have the equal sign. And over here, I would like to change that to become 6 to a certain power. Okay, so with the calculator, I'm just going to start guessing. I'm going to go 6 to the power of 4, and that's 1,296. So we still could continue guessing because it was too small. So let's go 6 to the power of 5. 6 to the power of 5, that's 7. That's exactly it. So 6 to the power of 5 is a representation, or is the value that will give you 7,776. Now that you have the same base 6, you could just scratch out the bases. You have a simple one-step equation, x plus 3 equals 5. So I really have minus 3 minus 3. We have the answer, x equals 2. Moving on to the last one on this section. Again, I would like this to be 3 to a certain power. So I want to go 3 to a certain power. Now over here we have 3 to the 3x plus 3, and there's an equal sign between it. And I want that 3 on the right side to be 3 to a certain power to give me 6,561. So again, I'm going to start guessing 3 to the 7th. That's 2,000. That's too small. 2,187. Too small. So 3 to the 8th. Let's try 3 to the 8th power. There it is, 3 to the 8th power. So on a calculator, just guess. And now you'll see that you could scratch out the base 3, and you have a simple equation, 3x plus 3 equals 8. And you could subtract 3 and subtract 3, and we will get 3x equals 5. And boy, did I mess up this problem because, well, who cares? It's just a fraction that we're going to get as an answer. It's okay. Let's divide by 3. Divide by 3. Cancels out. X equals 5/3. And that's how you do this section of the test. That was everything to do with radicals. The next video will be on exponential growth and decay, this next section.